I made a video recently about the Polaroid ultrasonic ranging system designer's kit, and it came included with these Polapulse power pack 6-volt battery, two of them, and a nice convenient little battery holder for the kit. And these things are approximately 28 years old. They're really no good as actual power supplies anymore, so I figured we'd have a look at them and do some dissection too. Now, these batteries normally would have been included inside the Polaroid film pack, and its main function was to power the flash and the ultrasonic ranging system if the camera had one, and most importantly, the motor that was used to spit out the film out of the package after it had been exposed. And it would have been one of these per pack and only 6 or 12 exposures. I forget how many there were. But it was very important that the battery be fresh for every single pack so that the motor would never hesitate to spit out the pictures, and you would never end up with a dead battery and a motor that didn't spit out the picture after you had already taken the picture, and the Polaroid company would end up with some very unhappy customers. And the reason for its flatness is, of course, so it sticks inside the film pack, and also its flatness gives it a very large surface area, so it has very low resistance, and it's able to supply the hefty current for a very short duration to turn on that motor and spit out those pictures. First, let's measure the internal resistance of the battery. I got the open circuit voltage here is 5.77 volts on one of them already stuck inside the battery holder made by the Power Card Corporation for Polaroid batteries. I don't know if that was a division of Polaroid or an independent company, but there you go. There's its information. So let's put that resistor in circuit here. 1 kilo ohm, and wow, it drops to 0.29. That's really bad. Let's do a quick calculation here. There's a 5.77 divided by the 0.29 minus 1 times 1000 ohm. We're looking at about 19 kilo ohm series resistance inside the battery. Very bad. Let's try the other one. And that's giving us 5.85 open circuit. This time I'll use a 10K. And goes down to 3.5 about. And here's the 5.85 divided by the 3.5 minus 1 and times 10,000 ohm, about 6.7 kilo ohm internal resistance in that particular battery. So a little bit better, but still, as it is, practically useless. Let's see how well these things can power up a blue LED. And there you go. Really not too bright at all. Let me put the other one in here. And this one's about the same brightness, maybe a little bit dimmer, but these batteries are certainly beyond their years. Okay, time for dissection. Let's see what these things are made of. It's real easy to peel this back because the adhesive is all dried up. So that's the negative terminal, and then the positive one here is this aluminum strip that's stuck to the outer sheet. There we go. Looks like most of it is just cardboard filler to make it the same size as the Polaroid film pack. Okay, so there's the aluminum container there. Let's see. Oh, here's some more aluminum coated paper that I can peel off of this. And it looks like I'm ripping it open now too. So let's have a look at this. Not sure what material that is, but certainly something stuck to this layer here. And on the inside, oh, we got plastic sheet. And then some black stuff. I forget what the chemistry is. I looked it up on Wikipedia, but I forget exactly what the chemistry is in here, so I'll put it up on screen. And I probably should be wearing gloves for this, but I'm not afraid of these chemicals doing any damage. I mean, it's very, I think normally this would be like an alkaline wet paste, but clearly it's been dried up by all the years. And we got another layer here, some kind of plastic, I guess. Not sure. And then, oh yeah, of course. These are all the individual cells stacked up. I guess it'll be 4 cells all stacked up in series. That's why we have these plastic layers in here, in between all the black powder. And I think I broke all the way through the other end. So there you go. I've got a nice mess to clean up, but that's the inside of one of these old Polaroid power packs. Thanks for watching. Now I gotta go wash my hands. Well, that cleaned up very nicely. I'm surprised. I was certain there would be at least a little bit of a gray smear left over on the surface here, but my hands are clean and the desk is clean. And I decided to do one more quick experiment with the internal resistance. I'm going to put the LED on here, and I'm measuring the current through it, rapidly dropping to 200 microamps and below. And I just want to see what happens when I apply pressure to the battery. Does the current rise? If I decrease, because I might be decreasing the internal resistance by compressing all that powder substance together, and it looks like, yeah, if I press really, really hard, then I can decrease that resistance and get some extra current flow. If I let it go again, actually it's doing pretty well now. Stabilizing at about, actually, whoa, something's going on inside the battery. Now the current's going up. It's all over the place. This is the one that was 6,700 ohm internal resistance before. Not sure what it is now. Let's do the resistor calculation again. 5.67 volt divided by 5.40. Minus 1 times 10,000 ohm resistor I'm using right here, and only 500 ohm internal resistance. So I don't know what the heck happened there, but I may have given this battery just a tiny bit more life than what it was before. And the LED is noticeably brighter. Even the forward drop voltage has gone up. I think it was about 2.6 volts before. Now we're at 2.8. Very interesting. See you later.